Hello. In this video, I will go over points, lines, planes, segments, rays, collinear and non-collinear by a formal definition and by a visual. So let's go over a point. A point is a definite location represented by a small dot, but a point can actually has no sides at all. So we name points by using capital letters such as point A, point B. So that's pretty self-explanatory. Yeah, so a point is by a capital letter. Okay, so what about a line? So a line is a perfectly straight path whose length extends indefinitely and has no width. Every line contains infinitely many points and is represented by a straight line with two arrowheads. So this is a line. Now we'll go over like rays and line segments. So notice that the arrows point on opposite direction. So that's how you know you have a line. And it needs 2 points to make a line. So you need 2 points to make a line, and this is how you represent a line. So you have to have two arrows pointing on the opposite direction. So you can call it line AB or line BA. Okay. So what about collinear? So collinear are points that lie on the same line. So they will ask you later on, or your teacher will ask your homework problem, what does it mean for something to be collinear? It just means they have to be on the same line. So this is an example of collinear. And this is also, so if you put this extra line here, line DG, that would be collinear because it's on the same line. So you have two collinear lines, this one and this one. Okay, so that's what collinear means. And so collinear points would be points D, E, F. Non-collinear points would be C, D, E, F. So they have to be, whoops, this is C, not G. So this is C. So C, D, E, F. So why is points C, D, E, F non-collinear? So if you connect them, here's C, here's D, and then you kind of like make an angle. So they're not in the same line. So that would be non-collinear. But point CD would be collinear. Point DEF would be collinear, right? Now let's talk about a plane. So a plane can be thought of as a flat surface with no boundaries and no thickness. Imagine a piece of paper or a wall that extends without an end. So in a plane, you will need 3 points to make a plane and must be a non-collinear. So that's really important. So in a plane, you must have a minimum of 3 points to make a plane and must be non-collinear. So they can be yeah, as you can see, this is in a perfect example. This is you have 3 points, points A, B, and C, and as you can see, they're non-collinear. So this makes a plane. And then here you have this capital M that's right in the corner. So that capital letter on the corner that represents plane M or plane ABC. So you can call this plane M or plane ABC. Okay. So in a plane, 3 points and non-collinear. What does coplanar mean? So then we just went over, what does coplanar mean? So our points that lie in the same plane, any 3 points are coplanar, any 3 points are coplanar, but three non-collinear points must be used to name a plane. Okay, so what does that mean? We'll do an example. So let me reread that. Coplanar are points that lie on the same plane. Any three points are coplanar, but three non-collinear planes. Three, but in order for a plane, in order for a plane to exist, those 3 points has to be non-collinear. Okay, so let's do an example. So we went over definitions. Hopefully let's prove it. So name an example one. Name each of the following points. So you have line AC. So we want to know what's a point that goes through line AC and line DB. So this is line AC here and line DB. We want to know what point goes through those two lines. So line AC is right here and line DB is there, DB here. What point goes through those two lines? Point E. Okay. This is still part of the same example. Name three collinear points. So collinear means they have to go through the same line. So name three collinear points. So I see that point AEC would be collinear, right? So AEC is collinear because they go through the same line. What else? What about EC, ECA? Yes, ECA are on the same line, so that would be collinear. What about CEA? CEA. So CEA, yes, that would be collinear. And then what else can we use? What about points DEB? DEB, yes, that's collinear. What about point DBE? Here's D, B, E, yes. And then what about points BED? BED, bingo. And there's one more we can say. What about points EBD? EBD, yes. Okay, so those are 3 points that makes it collinear. Collinear. Number 3 says write 6 different names for the line containing DEB. So if you look at the line in DEB, DEB is this line. We want to write 6 different names that contain. So we just want to rewrite line DEB. So we want to create some kind of line between the points DEB. So one would be line DE, right? Line DE goes through the points DEB. What else? How about line ED? That's true. Here's E and here's D. Yeah, line ED. Yes. What about line EB? B. Here's E and here's B. Yes, that would work. What about line BE? Here's B and here's E. Yes, that would definitely It goes through the points DB. What else? So we did BE. What about line DB? Here's D, here's B, yes. And then maybe the last one could be line BD. Yes. So that goes through the points DEB. Good. Okay. So number 4 says, can you make a name plane? Can the plane be named AED? Can the plane be named AEC? So what are three things in order to be in a plane? They have to have 3 points, so they both have 3 points, but they also have to be non-collinear, right? So let's see if that's true. So AED, here's AED. There's 3 points in a plane, and they're definite, and these points are what's called non-collinear, right? They're not in the same line. And then, so the first one is true. So, you could, yeah, so the second part, so the first part says, can the plane be named AED? Yes, because there were 3 points and they're non-collinear. Wait, so yes, the plane can be named AED because there's 3 points and they're non-collinear. What about can the plane be called AEC? There's 3 points, AEC, no. Why? Even if there's 3 points, why can't this be plane? Because they are collinear, right? They're on the same line. So they have in order for a plane to exist, they have to be non-collinear. So no. Okay. So yeah, that isn't a problem. Okay, now let's do another example. So here on this example, we have two planes, and then it goes through a line, right? So or you could think of it as like two pieces of paper, and then like a big, like a stick going through those two pieces of paper, if that makes sense. So you have two planes, and it goes through this line. Okay, so let's do some true or false questions. So does are points A, B, C coplanar? So where's A, B, C? Um, so what does it mean to be so A, B, C, what does it mean? What do you have to do for it to be coplanar? It has to be 3 points, and I believe they have to be non-collinear. So on number 5, it would, or this part, it would be true since there's 3 points. And in order for it to be coplanar, they have to be and they are non-collinear, and they are not collinear, right? They're not in the same line, so they are not collinear. Okay, so that would be definitely true. What about this uh, points ABC are collinear? So ABC, no, they're not in the same line, so they're non-collinear. Okay, so yeah, false. Points A, B, C are not linear. Okay, number 7, point F lies on line DE. Is that true? So where's point F? Point F lies on line segment DE. Oh, sorry, this is F right here. So does point this point F lies on line segment on line DE? No, that's false. Here's line DE. If it would go through the line DE, at point F would have to be right in the middle. So that'd be false. What about line DE? Does line DE lies on the plane DEF? So here's DEF. Does line BD? So does line DE lies on the plane DEF? DEF and then DE. Yes. Uh, here's the plane DEF, right? There's how do you know this is a plane? Because there's 3 points and they're non-collinear. And then line DE goes through line DE is definitely a line, so it's a line that goes through this plane. So it's going to be true. Okay. What about 9? Line BD and line DE intersect. Uh, the so line BD, where's B and D? So here's line BD, and then line DE intersect. Yes, right? Here's this line right here, line BD, and then it intersects the point line DE. Correct. So that would be definitely true. Number 10, planes ABC and DEF intersect. Planes ABC, so this plane right here, does that intersect with planes DEF? Uh, I'm going to say false. Why? Because you could think of this piece of paper as your ceiling, and then this could be like your floor. They're never going to touch, right? They don't intersect. So I'm going to say false. Okay. Let's continue doing some true or false. So all planes on a line are collinear. So what you need to do, remember, is so you need 2 points to make a line, and then you need 3 points to make a plane. You need a minimum 3 points to make a plane, and must be non-collinear, right? Okay, so all points on a line are collinear. Yes, right? If you have a line, here's point A, here's point B, here's point C, or here's line AC. They all have to go through the same point. So yes, collinear means going through the same line, points going through the same line. So yes, true. 12, all points in a plane are coplanar. Yes, all points in a plane must be coplanar. Remember, coplanar means they have to be non-collinear. So why is this true? So number 12, why is that true? All points in a plane are coplanar. So how do you, here's a plane. Here's point A, point B, point C, point D. So in order for it to be coplanar, you have to have at least 3 points and they have to be non-collinear. I mean, sure, you can have a line that goes through it. That's fine. Um, but yeah, you have to have some that are you have to have some that are they have to be all eventually non-collinear. So that's going to be true. Okay. 13, all points on a line are coplanar. Yes, it's true because all points on the line are also in the same plane. So they have to be coplanar. So you say all points on the line are also in the same plane. Okay, so all points on the line are also in the same plane. Okay. Let's go move on to 14. All points in a plane are collinear. That would be false, right? Not necessarily. So how, here you can have a plane, and yeah, you can have collinear points, right? That's definitely true. So you can have points here, points here, points here, point here, and then you might have some points that are collinear, like you can have 3 points, some points that form a straight line or collinear. So not all points in a plane are collinear, right? So what do you have to have in order? What does have what must exist in order for a plane to exist? You need 3 points, and they must be some points, and they must be some points must be collinear. So you may have a line that goes through it, but some points have to be non-collinear. So that's going to be false. 15. All right. Any 3 points are coplanar. Yes, any 3 points are coplanar. So I'm going to say true. So why is that true? So what does coplanar mean? So coplanar are points that lie on the same plane. Any 3 points are coplanar, but three non-collinear points must be used to name a plane. So any 3 points are coplanar. So yes, that would be true. 16. Any 3 points are collinear. No, not necessarily, right? You can have 3 points that are collinear and some are non-collinear, right? You can have a plane and you can call this point A, point B, and then remember you have to have 1 point that's non-collinear. So in a plane, they have to be non-collinear. So that would be three. That would be false. Okay. So let's talk about line segment. So it almost looks like a line segment is almost like uh, a line, but a line segment is a straight path that connects 2 points. So you have to have 2 points. The points at the end of a line segment are also called endpoints. A line segment is finite, so it stops somewhere. A line segment has a single dimension because it extends only in one direction. So here, let's look at examples. So this is line AB, right? And then line segment AB would be represented as a straight line with no arrows. And notice it says it's a finite, so it stops somewhere. In a line, it just keeps on going because of these arrows. So line segment AB would be expressed as this straight line over AB, or you could say line segment BA. Okay, so it stops somewhere and there's no arrows. That's the difference between a line segment and a line. What about a ray? Because you'll see that later on. So a ray is part of a line with just one endpoint. Rays are named by listing the endpoint first. So this like it starts at a position and then it ends somewhere infinity. So let's let me show the difference between a line. Here's a line. So in a line, um, there's two arrows. In a ray, there's only one arrow pointing in one direction. So it can move to the right, it can also be to the left. And yeah, so the difference is a ray is, for example, ray AB, here's point A, here's point B. So it starts at one position and then it never ends. It keeps on going. So that's the difference between a line and a ray. So in a line segment, the difference is there's a straight line. And in a line, there's two arrows pointing in both directions. An array, it starts at one position and it never ends and it never stops. So you have like one arrow pointing in one direction or one arrow pointing in the opposite direction. Okay, so that's the difference between a line, a segment, and array. Okay, so here this would be ray BA. So this is ray AB. So you start at A and then it doesn't stop. It keeps on going on the right. And then this would be ray BA. Right? You start at B and then it never stops. It never ends in the left direction. So let's say we had this ray A, B, C, D, right? Let's come up with some rays. So this can also be expressed as ray AB. This can also be expressed as ray AC. This can also be expressed as ray AD. This can also be expressed as ray BC. And then this can also be expressed as ray BD. Okay. Uh, Opposite rays have the same endpoints but point in a different direction. So this would be an example of an opposite ray. So yeah, so opposite rays have the same endpoint but point in different directions. So uh, ray BA and ray BC are opposite rays. So ray BA, where's BA? Right here. So it'd be pointing this way. And ray BC, where's ray BC? It would be pointing this way, are opposite rays. So on this example, name three different segments shown. So they're not asking for rays, they're asking for line segments. So you have this three collinear, you have these points and they're collinear, and we got to come up with different segments. So you can express this as line segment JL. You can also say line segment LJ. You can also express it as line segment JK. And then you can also express this as line segment KJ. And then you can also say line segment KL. And then you can also say line segment LK. Okay, so those are the different line segments. Okay, next one. List all the rays in this figure. So you have this. What is this? This is a line? See how there's arrows pointing in opposite direction? We have to come up with some rays. So one ray could be expressed as, I guess you could say ray JK. Another one could be expressed as ray KL. And then another one could be expressed as ray JL. And then another one can be, now we can also do opposite rays. So you can do ray LK because we're going on the opposite side, right? And then the other one could be ray LJ because you're going in the opposite direction. So ray LJ. Okay, let's do this example. So on this one, it says list all the rays. So you have two lines that intersect, and then point N intersects those two lines. So we got to come up with rays. So one ray could be expressed as ray ND. Uh, Another one could be expressed as ray NB. And another one could be expressed as ray NC. And then another one could be expressed as ray NA. Okay, now we could also express this as ray AB. So you start at point A and then it never stops at point B. So ray AD. And then another one would be expressed as ray DC. You start at point D and it never ends at point C. Ray DC. And then another one could be expressed as ray BA. Here's point B and here's point A. So BA. And then another one can also be expressed, it's just limited, right? CD, ray CD. Okay, so we went over, that's the last example. So we went over points, lines, planes, segments, and rays, collinear, non-collinear, and uh, what's the other one? Coplanar and plane, right? So yeah. Okay, so that's the last example. So we'll stop here.